How SpaceX mastered Starship welding techniques. The first Starship prototypes from SpaceX looked incredibly rough, far from something that seemed capable of surviving in space. However, Starships produced by SpaceX now appear much more refined, with smoother metalwork and less visible weld seams. So how did Starship evolve from its early, rough prototype to its current polished form within just a few years? And will it ever reach the sleek, mirror-like finish often shown in renders? To answer this, let's first look at why Starship appears the way it does, and specifically why it's large and shiny instead of thin and white like most rockets. Starship wasn't always destined to resemble a sci-fi rocket from the 1940s. Originally, it was meant to be made from carbon fiber, and production had even begun in California. This seemed like a logical plan, given that carbon fiber is extremely strong, and most SpaceX employees were based in California. So when a stainless steel Starship appeared in a small town in Texas, it took everyone by surprise. But over time, people began to realize how smart this decision was. While carbon fiber is incredibly strong, it starts breaking down at around 200 degrees Celsius. This means that a very thick heat shield would be required to handle the 1,600 degree temperatures during multiple atmospheric re-entries. Although stainless steel is heavier, it can withstand higher temperatures, needing only a thin heat shield. Stainless steel is also much cheaper, costing only $3 per kilogram compared to $150 for carbon fiber. But stainless steel rockets weren't new. Back in the 1960s, NASA built an Atlas rocket from very thin stainless steel. It was so thin that unless it was continuously pressurized, gravity alone would cause it to collapse. However, even with carbon fiber, it's hard to imagine how Starship was actually built. Carbon composites need to be layered in a very specific way to make the material strong in all directions, and then cured in a giant autoclave under high pressure. For a Starship that's 9 meters wide, SpaceX would have needed an oven larger than any on Earth. This is where stainless steel holds a major advantage. It allows for rapid assembly using basic, cost-effective methods. Thus, SpaceX began developing the world's shiniest rocket, although it didn't look that way initially. The first Starship prototypes faced a major challenge in welding. Initially, each ring was made from several 4.5 millimeter thick pieces of 301 stainless steel. Remember, the first Starship crew was contracted from a water tower company. They had no experience building rockets, so the welding standards weren't high. Welding is tricky. The early Starship prototypes used a method called flux-cored arc welding. In this process, voltage passes through a wire, creating an arc that melts both the wire and the metal it's attached to. The melted wire then fills any cracks or bubbles. The wire has a flux core that burns and releases gas around the weld, protecting it from oxygen in the atmosphere that could cause corrosion. This method works well in a controlled environment. However, at the time, SpaceX didn't have a real factory, just a large tent. Since most welding was done outdoors by welders with no rocket experience, it's no surprise the first Starship looked rough. The early welds were heavily corroded with cracks and rough edges. To improve the welds, SpaceX began grinding them down to be flush with the surface. While this seemed like a poor attempt to make it shiny, this process was actually intended to strengthen the welds. Sharp edges and micro cracks create stress points that could lead to bigger cracks when Starship is pressurized. Grinding down the surface removes these weaknesses, reducing the risk of weld failure. In theory, every weld should be as strong as the surrounding metal, but the first Starship test proved otherwise. One horizontal weld failed, blowing out the tank walls. Thus, SpaceX made major upgrades to the next Starship prototype. Now each ring is made from a single, thinner piece of stainless steel, requiring fewer welds. They switched from 301 to 304L stainless steel, which offers greater corrosion resistance during welding. They also upgraded to TIG welding, allowing better control of the welding arc. This enables welders to weld deeper, creating thinner welds with minimal warping of the surrounding metal. SpaceX also began purchasing robotic welders from Liberty and KUKA, similar to those in Tesla's factories. These upgrades automated much of the process, allowing for cleaner, more precise welds. SpaceX also added more stringers inside Starship's hull to prevent metal sagging. But SpaceX didn't stop there. They likely switched many parts of Starship's assembly to laser welding. Laser welding produces concentrated heat that penetrates deep into the metal, enabling a cleaner, single-pass weld around the ring edges. For even stronger welds, there's another process: work hardening, or cold rolling, which involves compressing and stretching the metal through rollers to make it harder. However, welding softens this hardened metal, which is where SpaceX's massive press machines come in. They hammer and compress the welds to match the hardness of the surrounding metal, which also makes the welds smoother and more visually appealing. But will Starship ever have a mirror-smooth surface like the famous bean sculpture in Chicago? That structure took 24 workers 8 months of polishing with various grades of abrasive grit to achieve its look. For Starship, the entire hull would need the same treatment to eliminate any visible lines around the welds. This is unlikely to happen. Regardless, SpaceX is fully committed to advancing Starship. SpaceX's culture of innovation and rapid iteration has greatly accelerated the development and optimization of its welding technology. Thank you for watching the video. If you love astronomy and the universe, please like and subscribe to the channel.